So now, as you can see here, we have this is the second part of commercial arithmetic that I wanted us to look at. It is called commercial arithmetic. Now, commercial arithmetic, in commercial arithmetic, we have this is the second part. Now, so we want to look at simple interest, and we want to start by asking ourselves what interest is. What is interest? Then we look at what is simple interest and the difference between simple interest and compound interest. Okay. Now, interest is the money charged for the use of borrowed money for a specific period of time. Interest is the money charged for the use of borrowed money for a specific period of time. Now, if you have a bank account, okay, you can deposit some money. The money that you're going to deposit or you're going to invest in that bank is called the principal. We call it the principal amount. Now, that principal amount, you're going to deposit it at for a specific period of time. So we have the issue of time there. So you can deposit for 1 month, 2 months before you withdraw it, 1 year, 10 years. So that is the time at that principal, the amount of money is going to be deposited. Now, each and every account has its own rate of interest. So the interest that you are going to earn at the end of a certain period of time, there is a certain rate of interest, which is a percentage. So that money is given as a percentage. Or that principal is going to earn interest as a certain percentage for a certain amount of time. And that is how you earn interest. So at the end of the day, you're going to have a certain amount of money. If you subtract the money that you invested or the money that you deposited, which is the principal, whatever you're going to get now is called simple interest. So for the simple interest, now that is how you can earn the simple interest. And we usually see that. Let me just come here. A moment. So we say simple interest, which can be abbreviated by SI, okay, is equals to, I've said you have to have some money called principal times rate. You multiply this one by rate. Remember, rate is a percentage times the time that you have, okay? So in short, we say simple interest is just a moment. Just a moment, just a moment, I admit these others who are joining. So you have simple interest is equals to principal. Then principal is multiplied by this one. Actually, I would have said principal multiplied by rate. Rate, remember, rate is a percentage. Okay. So rate is out of 100. Rate is out of 100. And then here you can now come and then you multiply by time. So principal times rate times time. Let me add a little volume here. Okay, so actually, yeah, so okay, no, that's not this one, but you are here, you are here. Just a few minutes, they can see the right thing. So times time, like that, okay? So in short, usually say simple interest is equals to, now we just now usually come here and then we say this. It is a principal, principal rate time over 100. This is how, finally, this is how we come and do it. So this is how we calculate now our simple interest here. This is how we calculate our simple interest. So you have simple interest is equals to principal rate time, obviously over 100. So you can just multiply the numerators and have the denominators like that. So this one is a very simple case. So like the examples we have here, for example, you can see here, what is happening here in this question that I've picked here, instead of being told to calculate for the simple interest, you have been given the simple interest, okay, which is 16,000, okay. So calculate the simple interest and the amount on 16,000 shillings for 1.5 years at 14% per annum, okay. So here we have been given simple interest. So simple interest have been told is 16,000. Simple interest is 16K, okay. Time is 3.5, 3.2, 3 over 2. Rate is 14%. So calculate the simple interest and the amount on 16,000 on this. Oh, sorry, calculate the simple interest and the amount on 16,000. I think this is not grammatically correct. So you are calculating simple interest, okay, on the amount of 16,000. So 16,000 now here is the principal. So actually it is direct. So 16,000 becomes the principal, okay. Then the rate is 14 over 100. Time is 1.5 years. So you can either use 1.5 or you can use 3 over 2, which means you make this one just this one is a mixed fraction. You make it a proper fraction. Then you are told what is the amount. What is the amount? So amount is simply whatever you're going to get after you add the principal, which is principal is the amount that was deposited, which is the 16,000, plus the interest, that is the amount that you're going to get here. So interest here, whatever you can see interest here is the one that I'm calling simple interest in this formula here. So simple interest is principal rate and time. So you just multiply directly. So 16,000 rate is 14 over 100, or you can say 0.14. This one is 3 over 2, or you can say 1.5, and then you can see the amount of money you're going to get here. So you just multiply it directly. And then I said amount, just like I was explaining to you when we were starting. Amount now is the total amount you're going to get. That is the amount of money you deposited plus the interest that you have earned. So you can see 16,000. If it is deposited for 1.5 years at a rate of 14% per annum. Per annum means per year. It means that the amount that you're going to earn is 3,360. Okay. So you add the 16,000 that you had gotten. So at the end of the day, your account is going to have just 19,360 shillings, which is really little money if you consider that. So this is how you earn simple interest. And it is for that regard, where we now go for another alternative, that is the compound interest. Now, remember today I said I wanted us to start the topic of statistics, so I'm just going to show you what that one is, and then we can move on. So just give me just a moment so that I can have just a moment, one moment. I'm hoping that whatever I'm sharing can be seen. Let me share something else, but you can have a difference of this. Share. Good. Okay. So I've seen the other someone might is on coordinator. So the other option now is compound interest. Okay. Now simple interest is like compound interest but done differently. Now you see this particular case. So you see there's a person here who was investing this amount of money. For example, let's say they were doing it for 1.5 years. Let's say they were doing it for 1 year. Okay, let's say this person deposited 16,000 times the rate of 14% per annum. That is for only 1 year. So let's just do that example very fast and show you how it is different from the other case. So it would have been here. You come here, it would have been 16K multiplied by what? 14%. 14%. Okay. Sorry, 14% multiplied by 1. Multiplied by 1. So the amount there is what? You can give me that amount. That is for the first year. So first year, if you are, for example, this is the first year. Okay. Then we now go to the second year. Second year, in simple interest, you'd have still done for the same. So 16,000, you multiply by 14%, and then you multiply by another 1 year. Sorry, 1 year. Okay. So if it is like 3 years, you follow the same process again. So for the third year, you just come here and then you get the same. Please, I'm hoping that you have your calculators ready because today we are going to do a lot of calculations. So for the third year, this is what you have done. So you see, you are getting the same amount for the every year. This is what simple interest is. But now compound interest, what we do is, for example, in the first case here, I just do it very quickly. So I'm just going to calculate it here. I'm not going to share my calculator because I want to do it very fast. Now remember, you have your calculators at home and they don't want to be doing everything for you. Okay, so 16,000 times 14%. Times this is 2,240. So I've got this one is 2,240. So this amount you are going to maintain it in the for each year for the time that you're going to deposit this money that you have here. Okay, this is simple interest. But if there was compound interest now, what happens in compound interest? At the end of the first year, okay, at the end of the first year, the 16,000 is added to this. So this amount here is added to the 16,000. So you now come and add this one to 16,000, which now becomes 18,240. So for the second year, instead of you depositing it as 16,000, you are now going to deposit 18,000. You're now going to come here, you say 18,240 multiplied by 14%, times 1 year, okay? Times 1 more year now. So in the second year, this is what you're going to get in compound interest. So this one here was for simple interest, but this one now is compound interest. Okay, so 18,240, you multiply this one times 14%. The amount of interest you will get here is this from my calculation here, 2,553.6. Those are the 660 cents. So this is the compound interest that you have earned. So in the first year, compound interest, this is what you did. Okay, so you added it. So for the second year, this amount of money you're going to deposit here is going to earn you this interest here. So for the other year now, so you are going to add now the 18,240. So you come and add it here. Plus 18,240. So what are you going to have? You're going to have 20,793.6 or 60 cents. Okay. So for the third year now, this is the amount of money that you're going to deposit. This one here. So compound interest means you keep on adding the interest to the principal before you go to the other year. So you now come here and then you multiply this one by 14%. Okay. Times 14% times the 1 year now, times another 1 year here. So this one I come and multiply by 0.14. So I'm going to get an interest of 2,911.104 cents. Okay. So then this one I'm now going to add it to. I now add it to this to see what I'm going to get. So I say plus 20,793.6. And so I'm going to get 23,704.704. So this is what I'm going to get. So this is what is called simple interest. This is what is called simple interest as compound interest. Sorry, but you see, simple interest was rather direct. So for the first year, simple interest, you're getting this. Second year, the same amount. Third year, the same amount. So for compound interest, we don't do it like that. We keep on adding the interest at the end of each year. Then by the time you start the other year or the other time period. So if it is annual, it means per year. So you add 16 times the principal, it was 16,000, you get this. So for the second year, you are going to use this one as the principal. It's going to earn you this as a new interest that you're going to have here. So you add it again to the principal amount here. So you get this one as the total amount. Then finally, it is going to earn it. So you can see the interest keeps on increasing. But for the simple compound interest the interest keeps on increasing. But for the simple interest, it was the same for the 3 years. So that's why we prefer compound interest. Now, instead of doing all that, there's a formula that is there, which is told to get the amount A. Okay, so this is just a formula of a simplification of the compound, the simple interest, so that we can come up with a compound interest. So we can notice that A is equals to P into brackets 1 plus R over 100 into power n. So let me come here and see. So the formula usually is A is equals to P, and then you say into brackets, okay? Then I can insert now my formula here. 1 plus 100. 1 actually is not over, let me delete this. 1 plus, then I can now insert this. This one is R, 100, and then here we say into power n. Into power n. This is how we do it. So A is the amount. So A is equal to the amount. And then here we say P is equals to principal. So this is the amount of money that you're going to deposit, okay, or invest. So deposit, stroke, invest, okay. Because in some other questions, it is not only going to become just you deposit money in a bank. No, you can invest money in a business. You can invest in buying something and all those other things. So R obviously is rate, which normally we usually give this one as a percentage. Okay, and then we have N. N is the time periods. Sorry. N is the time periods. N is here. So N is equals to time periods. Now I want to say what time period is. You see, N, in some cases, the N is going to change. Like, and an example that I want to show you just here. Okay. Let me first of all take the attendance. And then let me take this attendance and then I can do it. Remember, I keep on taking attendance. So I look at the average time that you have attended the class. Some people just come and they think that because you have come for 1 minute, I'm going to, no. Attendance should be something that is consistent. Remember, the class is 3 hours. You need to come to the class for a substantial amount of time so that they can regard you to as having come to the class. So time period. So I want to show you that example. So just hang on a minute there. I want to find that example here. Not supposed to be this. Is good. Hoping that you're still there. You're still there. Hoping that you're still there. So let me end the last one. Okay, this very important. Good. What is happening here? Okay, so okay, here we are now. So let's come here and see what happens for the time period. For example, now in compound interest, this is what a question in compound interest looks like. What would 15,000 amount to? Okay, so the question is amount to. So 15,000 is the amount of money that is deposited or invested. So the mix is the 15,000 the principal amounts to after 3 years. Okay, so time is 3 years. But what is the time period? At 16% per annum, this is the rate per annum. Per annum means per year. But look at compound interest. Compound interest can be done in a number of ways. It can be done annually. It can be done quarterly. It can be done semi-annually. It can be done monthly, and all those time periods. So this was my interest here. My interest here was about the time periods. So let me just come here. So we have something we call the time period. So compound interest can be so this one can be done. Compound interest can be done annually, which means annually, you know, it's per year. Okay, can be done semi-annually. Okay, it can be done quarterly, like in this example that we have here, and then it can be done monthly. And this is why I'm going to add this one now. Just explain this one, then I'm hoping that we can now embark on the topic that I wanted us to look at today. So time periods, compound interest annually. Annually means per year, okay? So this one is straight. If it is annually, if it is compounded annually, so here you are going to find the name compounded annually. Then here compounded semi-annually, compounded quarterly, okay? So this name here is a very strong name, and it has a very strong meaning. And my main aim is to show you how to calculate this, and also to give you also is a perspective, so that if you want to choose a bank account, you can maybe choose the best one. So compounded annually is compounded per year, which is straight. So you just do it direct. Okay. So when it comes to n, for example, if it is 3 years, compounded annually for 3 years, your n now becomes 3. Okay. If it is compounded annually for 3 years, your n becomes a 3. Okay. But if it is compounded semi-annually for 3 years, 3 years, okay, 3 years semi-annually. What does that mean? Semi means a half. So it means in 1 year, how many halves are there? Okay, in 1 year, how many halves do we have? 2 halves. Or 2 semis. We have 2 halves or 2 semis. So if it is compounded semi-annually, what are we going to do? Now, let me come to this case. Compounded quarterly. Okay, so how many quarters do we have in 1 year? How many quarters do we have in 1 year? 1 year. How many quarters are they? Okay, it means there are 4. Quarter is divided by 4. Okay, monthly. How many months do we have in 1 year? In 1 year. That one is, these are just pretty obvious questions. So that now brings us to the question. Okay, what would 15,000 amount to? 16% per annum. Angalia, 16%, the rate is per annum, but it is not compounded per annum, it is compounded quarterly. So 16% per annum, compounded quarterly. Let me bring you to the questions that I've put here. Okay, 5%. So 8,500 invested for 2 years at 5%, but compounded semi-annually. So that is what it has. The rate is per annum, but the compound interest is being done here. Okay. So here, the rate that you're going to be given here, let me come here. For example, here, we want to do this rate. A rate which is done per annum, this is abbreviated per A, but compound interest, but compound interest is okay. So the rate per annum now here is per year. So if it is compounded annually, it means n is equals to 3. But if the rate per annum, in this case, it is very different. The rate is per annum, which means per year. But compound interest is done half a year. So we have to ask ourselves, what is n and what is rate? So the n changes and the rate also changes. How do we do that? So I'm just going to take an example here like what we have here. For example, let's say rate per annum is 16%. Rate per annum is equals to 16%. Is equals to 16%. So this one is compounded annually. So the rate per annum is the rate per year. Compound interest is annually. So nothing changes. The rate remains the same. N becomes 3, which means it's 3 years. But if it was compounded semi-annually and the rate percent is still 16%, okay, then this one now changes. Because you can see the rate is per year, but compound interest is done for half a year. So I have to ask myself, how many halves, how many semis are there in 1 year? Which means there are 2. So n now we say 3 now times the 2 here, the semis. So n now becomes 6. So n is not 3, it is 6. What about rate? So n is multiplied, but rate is divided. So you take 16%, okay? You take the 16%, you come and divide this one by, you have to divide this one by the semi. Semi, it means 2. So 1 year, you have to divide it by 2. Because you can see this rate you have been given here is per year. Okay, this is the rate of per year. But compound interest is done in halves. So you have to divide this rate here by a half. So 16% to divide by 2, what are you going to get? That is now going to be your new rate. 16 over 100 multiplied by 2. So it is very simple. I can show you the long way so that you can now be able to do that. 16 over 100. You now want to divide by 2. You come here and then you divide this one by 2. You divide this one by 2. So what are you going to get? Just a moment. So the answer there is obvious. 16, if you divide it by 2, obviously you're going to get 8%. So 8%. So if it is, let's say you are investing, let's say in this example, let's say what principal is equals to 15,000 in all these examples. So in this case of compound interest, this one it would have been the principal of 15,000. Okay, 15,000. The equation will look like this. What would 15,000 amount to after 3 years at 16% compounded? Now we are doing semi-annually. So what would 15,000 amount to after 3 years at 16% compounded semi-annual? So we come here. What would 15,000 amount to? I think you now understand the other part of the equation. So you have computed two things here. We have computed in our formula. We have computed. We are remaining with 10 minutes, and I'm hoping that you're going to be through in the 10 minutes, so that we start with something else. 1 plus. Come here. You put the R here. 100. This one is into power n. So the n is here. So I think all of this needs to be changed. Okay. So that now this one is like that. Okay. So you now see it is quite different. So you now this one is quite different. So amount is what you are calculating. A principal is 15,000. Okay. So you now come here and see 15,000. 15, 1, 2, 3. And so you just input them in your calculator. Actually, you do it together. So this is 1. Then here you see plus. R, the rate now has changed. Okay. So it is 8%. So it is, you come and you just put this one here. Just put it here. And then you see the time periods is 6. Because it is 3 years semi-annually. So 3 times 2. So this one is now 6, which is into power 6. And you put that one in the calculator, and then you just get an answer. So using your scientific calculator, what you start by doing, I'm not going to give you the answer to this, so I'm just going to show you. Okay, using your scientific calculator, what you do is you start by saying 8 over 100. Okay, or you say into brackets 1 plus 8 over 100. When you get that answer, you multiply it by 6. You say into power 6. So this is where you start. Nani huyu anashinda kisumbua sasa. Okay. So you start here. Okay. So you take 1. So you say, or you can start even by 8 in your calculator. So you can say 8 divide 100. Okay. So you say 8 divide 100. You say equals. So you get the answer. Then you say plus 1. Obviously, it will give you an answer. And then kuna hii power. Power, I think in your scientific calculator, huwa inakaa namna hii. It looks like, I don't know, I'm going to get it very fast here. This, it looks like this in your calculator. And then you say, you put 6 here. Okay, you say equals. And then finally is when now you come and then you multiply by 15,000. So you get the answer, and this will be your A. That is how simply you can get the A. Okay, let me come to quarterly. So quarterly, what is going to happen to quarterly? Quarterly, it means in 1 year there are 4 quarters. So quarter, it means it is divided by 4. So if the same 15,000 was compounded quarterly, so actually we want the rate. So it was a 16%. 16% per annum, compounded quarterly. So it means we ask ourselves, what is going to be the N? And then what is going to be the T? So that's what is very, very important. So N has to be multiplied by this. So obviously, we are going to say N times 4. Okay? And then we are going to say T divide by 4. It's as simple as that. So T, you're going to divide it by 4. Okay. Monthly. N is equals to, so N in monthly we multiply by 12. Okay. And the T is going to be divided by 12. T is going to be divided by 12. Yeah. So this is how it is. And then it changes everything. So N, that's why I said N is time periods. N is not the time. At the number of years. N is not the time, number of years. Number of years. Years. No. Capital, no. No, no. Time period means the time period. So as you can see here, we are for compound interest is different. Okay. So you have to know what time periods are. Like in this example here, you can see for every year we have 4 interest periods. Okay. That's in 3 years we have 12. So time you multiply by, come on, quarter you multiply by 4. And then rate you divide by whatever. This is how you do it. Okay. Find the accumulated amount if 20 interest is deposited for 3.5 years. This one is direct. So this one will just come and feed it direct. So this one is a direct example of the same. Okay. So 3.1/3, amesema 3.1/3. This is how they have done it. 3.1/3 years. So 3, amefanya 3 years, and then kakuja kafanya a third of an year, which I'm sure you can also get the same by changing this one into an improper fraction. So a man wants to have not that. Okay. So if it is compound, these ones are direct examples of compound interest. Okay. So 8,000 principal invested for 2 years. So time here becomes 2. Rate is 13% per annum. So this one is just direct. But when it comes to this one is not direct, like it would seem to be. This one is not direct. So this one you have now to change. Okay. So it is 2 years at 5% per annum, but compounded semi-annually. So this 5% has to be divided by 2. Then 2 years has to be multiplied again by 2. So you need to understand this concept here. Okay, you need to understand this concept that we are looking at here. And then this one is very, very important. And this is there was the remaining bits that I wanted to ask you to do, so that you can now understand it properly. So then we can, if the question comes about this, you can be able to navigate about it. And this issue now is the one that is confusing, because students come and do it directly. Now, na fail tu pale kwa rates na pale kwa end, the time periods. That is why you where you fail. So it is very, very important to know this is a compound interest formula. And if you are told compounded, semi-annually, compounded, whatever, you have to change this one according to how the question has been framed. So that one is very, very important.